Assalamualaikum and hello everyone. Welcome to the video for 3.3 Electrolytic cell. Okay, in this video, what we're going to learn is to predict the electrolysis of the following electrolyte. Okay, we have looked previously for the case of molten salt and water. In this video, what we're going to look at is actually concentrated and diluted NaCl and Na₂SO₄. And then we will do a quick recap or summary based upon this one. The influence of the standard reduction potential, concentration of the species, and the nature of the electrodes on the electrolytic cell. Okay, so previously we have learned this one. This one yang quite a lot kan? Okay, so let's continue with the examples with the notes on your page 16. Okay, so here we mentioned about electrolysis of NaCl. In this case, we're going to look at two cases, diluted and concentrated. Okay, so this is actually an aqueous solution. So when aqueous solution means that there's the presence of water. Okay, so that's why we have our water. Only the molten salt, we don't have the water presence because here they mention no presence of water. Okay, so let's look for the electrolysis of NaCl. So since the N aqueous, so again contains the H2O. Okay, how do we get the Na plus NCl minus? I'm just going to write down the equation. NaCl aqueous, we get Na plus aqueous plus Cl minus aqueous. So again, the species presence, we have Na plus Cl minus H2O. Okay, so for the anion and cation, I'm just going to write down based upon this equation. Okay, so I'm just going to write down here. Okay, but then for this case, for the electrolysis of the NaCl, we have our aqueous. So H2O, which one to put? Okay, is it an ion cation? So what I'm going to write down is actually I'm going to write down on both sides so that it's easier for you to see that that is the choices that we have. Okay, so for the case of anode and cathode, we have two choices here. So which one we have to choose? Because it is given to you, we have two species to be chosen. But because previously what we have learned, the molten salt only got one for each cation and anion. Okay, and then for the water, we only have H2O as the reactant. So it is easier lah for us to do the redox. But here we have two choices. So which one to choose? Well, you cannot choose more than one lah. So here let's look for the basic of it. The basis of it. First for the anode, we will pick the more negative one. Then the more negative, oxidation, easier to oxidize. More negative, it is easier to oxidize the anode. So here we have, this is the equation that we want, which is the species of our H2O. The H2O will be chosen for your anode, the reactant. Cathode, more positive, while more positive at cathode. Cathode is reduction, where reduction gain electron. So more positive is easier to gain electron. So here both is negative. So choose which one is nearest to zero to pick the one that more positive. But this is only applicable when the value is both negative, which is our H2O as well. So I'm just going to choose H2O. So for the anode and cathode, the reactant is H2O liquid. Okay, so here it seems familiar. Which equation? Okay, in the exam, the equation is not given. So actually, you have to memorize it. Okay, again, this is actually basically what we have learned previously. But then before that, I'm just going to write down for anode, oxidation, lose the electron. For the cathode, reduction, gain electron. Okay, so first, write down the electron first. Later, we're going to write down, okay, what is the other product? It's actually the same as the electrolysis of water. So again here, what is the product? So let's do it together. Remember that for the product itself, what we have learned, the tips to remember it, to remember the product for the gas and the aqueous is first for the gas, check in the middle of the letter. That in the middle of the letter is the hint for your gas. Anode, oxygen, cathode, H2. Okay, so that is actually the hint for the product of gas. For the aqueous, for the cathode, OH, so it means for the cathode, while the anode must be the H plus because water contain H plus, H minus. Okay, so that is the equation. But is it balanced? So if it's not balanced, how to balance it out? Follow the outer. Okay, the atom is not included here. Okay, let's check for oxygen. Oxygen, anode on both sides. So make sure 2 oxygen on both sides. Hydrogen, check here for. So the product must be for hydrogen. Next, check the charge. Here is 0. So here positive 4, 0. Okay, we want it to be 0, so we must add 4 electron. Later we'll get 0 on both sides. Now here we get 0 on both reactant and product. So for the cathode, okay, oxygen is balanced, both side 1, but the hydrogen is not balanced. 1 is 2, 1 is actually 3. So how to balance it out? I want to make it even to 4 hydrogen. So 2 H2O. Okay, and then I'm gonna add the H2O, the 2 OH minus. Okay, so again, check again the oxygen. Both oxygen is 2 on both sides. So we can proceed to calculate the charge. Charge here is -2. So on the reactant side must be -2 as well. So it will come 2 electrons. So both sides -2. Okay, so for the overall one, we have to simplify the equation by make sure the gain or loss of electron must be the same. So here we will multiply by 2. So from this equation, what I'm going to write down again is actually we will get 4H2O plus 4 electron equal to 2H2 plus OH, 4 OH minus. Make sure it is the same. So this one, the top and the bottom equation is the one that we are interested in. So I'm just going to make a square here so that you will not get confused which one is the one that I will simplify the equation. Okay, here, so we have on the same side water, 6H2O liquid. Then electron is being cancelled out because there's gain and loss of electron. Okay, and then I have my oxygen and 2H2 gas. Okay, and then for the 4H plus and OH minus, we will form our H2O liquid. H2O is always liquid, it's not an aqueous. 4H2O liquid. Okay, this equation could be simplified further by removing the 4H2O. So the 6H2O only got 2 left. So 2H2O, the O2 gas plus 2H2 gas. So this is actually the equation. Quite a lot of steps, but then it is the same as the one that we have learned during the decomposition of water. It's the same one. So it's actually accurately exercise for you to know how to write down the equation. Okay, so H2O and cathode. Okay, remember for the product itself, the hint here is based upon the letter itself lah. Observation must refer to the product. Okay, so the product check for each of the anode and the cathode, not the overall equation. Okay, so as it is the same as the water one, so what I'm gonna do is actually I'm gonna copy paste it here. So that is actually for the case of electrolysis of diluted NaCl. Remember, for the observation, must follow the equation. Okay, so that is for the anode. Okay, and then the cathode, H2 gas and OH minus. Solution is basic. Okay, so next we have done the diluted NaCl. Next is for concentrated NaCl, where we have different case. But still the same equation, NaCl equals Na plus equals Cl minus equals. And then I'm just going to write down, still have the presence of water, even though it's concentrated, but it's still an aqueous. Okay, so I'm going to write down, it's actually the same one, the anion and the cation. Okay, the choices is the same, but which one I'm going to choose? Itu yang lain dia. Okay, when we look here for the step 3 at the anode, here actually ada exception. Memang even though the basis of it, kita akan take the one with the negative one. But then for the exception, there is a high concentration of halide. Halide is your Cl minus or Br minus. Okay, then you have to choose the concentrated one. Here we have concentrated Cl. So that's why lah, we have to take into account anode. Pick the one that which is concentrated ion. Okay, why? Because actually the presence of Cl minus is much more lah compared to water. Even though water ni have lower inert value. Okay, so for the anode, we will choose this one, the Cl. Okay, and then but then the cathode pick more positive. But why pick more positive? Sedangkan we have it as concentrated. It means that we have lots of Na plus kan? Okay, why? So let's look back on the notes here. Here it mentioned that the cathode, reactive metals are never produced. We have sodium here kan? Never produced, never. So that's why we will never choose sodium. Walaupun dia concentrated macam mana pun, it will never be produced. So pick lah the more positive dia, kita pick our water. Okay. So for the anode itself, so for the anode itself, remember the first one is actually the reactant is my Cl minus cathode H2O liquid. Okay, Cl minus equals and the cathode H2O liquid. Okay, next when we check again, so for the case of anode oxidation, lose electron. So we're going to show it will lose electron. Okay, so when it lose electron, what about the other product? Again, the stable element for Cl is actually Cl2 gas. So we have to write down the product to be Cl2 gas. Next is make sure the equation is balanced, not only the atom, the charge as well. So atom here is not balanced, so 2Cl minus. Next, check the charge. So here -2, here must be -2. So the electron must multiply by 2. So next is for the H2O reduction gain electron, so plus electron. Okay, but then again, what about the product? Okay, product for water, okay, cathode, remember, the gas, check the middle of the letter there. So the middle H, so H2 gas, and then for the cathode, we have our OH, so plus OH minus equals. Okay, so that's the equation. But then again, how to make it balance? So yang ini kena tengok yang outer ni lah. Because we have quite a lot kan. It's not straightforward macam Cl. So check oxygen balance, hydrogen is not balanced yet. How to make it balance? I want to make it both side for hydrogen. So here is 2. It's actually here 2, betul kan? So here sepatutnya 2 OH minus. Okay. So here what we get is actually for hydrogen. So check the charge here. Here is 0, -2. Here 0, -1. To make both side 2, so plus 2 electron. Okay, so for all the overall one, we have to simplify the electron. Where one is loose, one is gaining electron. So when we write down the equation itself, so make sure the electron is not included. Lepas tu ni tersilap, make sure dia 2H2O. 2H2O, okay? Okay, so that is the equation. Okay, how about the observation? Observation must depend on the product. Okay, so for the anode, we have chlorine gas. So chlorine gas is produced. Okay, how about the cathode? Okay, for the cathode, we have H2 gas and OH minus. So the same as previous one. So I'm just going to write down, copy paste lah. Hydrogen gas is produced. And the solution is basic. Okay, so that is for the case of concentrated NaCl. The diluted one is the same as water. Concentrated NaCl, the one is different is the anode. The cation is the same. Masih lagi water. Okay, so for the electrolysis, diluted dengan concentrated ni, ni ada differences dia. So for the concentrated, where the ion is chosen is the Cl minus, Br minus only. Kat sini dekat point number 3. High concentration of halide, Cl minus and Br minus. Next, we will look for the case of electrolysis of Na₂SO₄, which is N equals. So for the case of electrolysis, we will assume all of it is equals except for our molten salt. Molten salt will be the liquid. Okay, so what is the equation? Okay, for the equation of Na₂SO₄, we will form Na₂SO₄, we form Na plus SO4 2 minus. Make sure the equation is balanced. So here we have 2 Na plus. Okay, so the species present is actually Na plus, SO4 2 minus, and then we have to include, don't forget, the equals must contain H2O liquid. Okay, so for the molten salt, only the one that has no water. Okay, so for the case of anion and cation, still here I'm just going to write down. Okay, and then for water, even though it's not anion or cation, I'm just going to write down there to see that that is the choice that we have. So then it will be easier for you to choose which of it will be oxidized or reduced. Okay, so which one will be chosen? Okay, because here is there's no mention of concentrated halide. So we're just going to pick the default one where the anode must be more negative because anode negative easier to oxidize. Okay, so which one is actually our water? Cathode more positive cathode, reduction, so easier to reduce. Okay, so oxygen losing electron, reduction gain electron. Okay, so for here, okay, we're going to choose because both is negative, we're going to take nearest to 0. So we have our water to be more positive. So in this case, both anode and cathode is our H2O liquid. So it seems familiar and you should be able to detect it actually. So actually it is the same as the equation of electrolysis of water and diluted NaCl. The same one. which this equation yang quite a lot steps kan, yang inilah. So what I'm just gonna do is actually for me, I can just copy paste it around kan. So this is actually the equation, the exact same thing. Memang itu. So sebab there's no mention about concentrated kan. So again for the product itself, hint dia in the middle of the letter here to mention to hint of the gas, and then cathode OH minus because selected OH. Since one is OH minus, another one must be H plus lah. Okay. So that is for the product. Make sure the equation is balanced by using the archer. Oxygen, hydrogen, charge and electron. And observation is based on equation which must be based on your product. Okay, so that is for the Na₂SO₄. Okay, here electroplating is actually an exception. This is the last one. Okay, choose at the anode ni, the last one, active electrode. Electrode dissolve to form metallic ion. Okay, so how? Okay, so let's look here. For this equation, we have AgNO3. So what we have Ag plus and NO3 minus. Okay, so here what we have, the species present must be Ag plus, NO3 minus, as well as our, remember since this is an aqueous, so there is always the presence of water, H2O liquid. So here I'm just gonna write down what is the anion and cation and water. We have to write down both so we can see the choices that we have. Okay, water. Okay, but that is the species present. But right now, for the case of electroplating, it's actually active electrode. The electrode will be involved in the reaction itself. So that's why for the anode, we'll pick active electrode, which electrode must be your solid lah. As you can see yourself here, your electrode is a solid. It's a metal plate. So here is the reactor must be the Ag solid. Okay, and then for the cation, for the cathode, we will pick more positive. In this case, we're going to see it as Ag plus aqueous. Okay, so that is actually for the anode. Remember oxidation, losing electron. Okay, so when we see here, make sure it's balanced. Not only the atom must, but the charge must be balanced as well. One argentum, and then the charge both sides is 0. Okay, for the cathode, it's reduction will gain electron. Then check it again whether it's balanced or not. So argentum one atom on both sides, and the overall charge is 0. So that is actually the equation. For this one, you don't have to write down the overall. Okay, observation, usually we refer to the product itself, kan? But how to write down the product? For the anode, the solid has dissolved into Ag plus aqueous. Because later we want to electroplate, we want to plate the ion itself, kan? So here mentioned that the electrode or the silver will become thinner. Why? Because it's actually dissolving into Ag plus into the solution itself. So that is actually for the anode. Okay, it is used in the reaction, so that's why it is thinner. The inert electrode does not involve, kan? This one is active. So for the case of cathode, what will happen is that spoon ni will be plated, will be coated with our silver. Sebab tu lah produk kita cathode tu silver solid, because actually it's being plated lah. The spoon is being plated with silver. Okay, so that is actually the last one for the electrolysis. So we have looked for the all cases of electrolysis. So back on your notes on page 14 itself. Here is the factors affecting selective discharge. Here predicting the product of electrolysis, which we have done all of it in the equation. So here is actually the summary, because actually in our syllabus we only have to learn these 5 things lah. But then for the equation we learn 6 because we have our electroplating. Okay, so first thing first is actually identify the movement of ion present. For the case of molten NaCl, molten is mean that the salt is melted from the solid to liquid. The ion present is Na plus NaCl minus. Okay, remember at anode it will be interested in the anion, the negative charge. The cathode is interested in the cation, the positively charged. So from here, for the case of Na plus NaCl minus, here we have our anode to be NaCl minus liquid. Here is Na plus liquid. Okay, only for this case is sodium is chosen, because here we mentioned that reactive metal are never produced. But for the case of molten, is actually the exception, because we don't have anything other than the Na plus itself. So that's why we have to choose the Na plus. Only for the case of molten. So Okay, so for the water itself, we have H2O, only the H2O. So for the anode and cathode must be the H2O as well lah. The H2O species, H2O liquid. Okay, and the thing for the water is actually the equation tu yang macam leceh sikit. Okay, remember that for the equation of water, for you to remember it, for the product actually, the one that is tricky, the middle of the letter there is actually the hint for your gas. And then for the ion, cathode is easier lah, OH, so OH minus. So hence the anode will be the H plus. So that is the species. Okay, for the diluted NaCl, okay, so it's quite a lot of choice. It's not quite a lot, it's just that you have another choice. Here, the starting 3, 4, 5, it's actually for the species to be selected at anode and cathode, you must choose it. Actually depends on several factors. For the diluted one, it's actually the same as the case of water. Okay, so we're going to choose on both sides must be the H2O liquid. Okay, but then for the case of concentrated NaCl, okay, because here concentrated halide ion here. Because here we have our reception that contains high concentration. So for the high concentration of halide, at the anode must choose our halide ion. So at anode here, here is the exception is my Cl minus equals. But then the cathode will be H2O. Okay. So that's for the case of concentrated NaCl. Last but not least is our sodium sulfate. So for the sodium sulfate, so it's the same as water, where we're going to choose for the both anode and cathode. Species that are going to be reduced or oxidized is H2O liquid. So as you can see, most of it for number 5, 3 and number 2, all of it is actually where we choose water and anode and cathode. So that's why it's important for you to memorize the product here lah. Equation usually is not given. Okay, and then remember for each of the equation, it must follow the most basic thing that we have learned in chapter 3. And oxidation occur at anode, and what is oxidation is losing electron, L2 losing electron. At cathode, reduction occur, where reduction is actually gaining electron. Okay, so that's the last of your electrolysis.